Okay, I'll just check you can all hear me okay, just whilst people trickling. Still good? Lovely. Let's check the clicker works. Yeah, that looks roughly like me, so it seems like I've got the right presentation. Okay, could we a little louder at all at the back, if possible? Any better now? Maybe? Okay, well, we'll see how we get on with that. Oh. Okay. All right then. Okay, is that better for you? Wonderful. Right, hello, yes, my name is Lee Dunkley. I've been in software like 15 or more years, which is possibly showing. I've spent a lot of that time actually working in the front-end side of things. But over the last 4 or 5 years, I've got more and more interested in the modelling of systems, which is what brought me to domain-driven design. So certainly can't quite claim to be an expert just yet, but with lots of wider reading, trial and error, and wonderful conferences like this, I've learnt that domain-driven design has a great number of benefits. And one of those benefits is that it can help prevent Emu Wars. For some reason, I think Eric Evans forgot to put this in the original book. It's also not in any of the spin-off books. So this talk is my silly little attempt to fix that glaring omission. So how are we going to do that? We'll go through it in about 4 parts. So first is a sort of short history lesson that serves as a somewhat silly code analogy. Then in part 2, we'll use the same sort of problems that we saw before, but at a more realistic domain. Part 3, domain-driven design, and some of its sibling practices come in to try and help us with the problems we've been facing. And then part 4, just a little wrap-up and summary at the end. So you might be able to tell from my accent that I'm not originally from here. I moved to Australia about 5 or 6 years ago. And I must admit, before then, I only knew like the classic dangerous Australian animals. You know, I've been told about the snakes, obviously a little bit worried about the spiders. I'd had plenty of Australians warn me about the drop bears. They've yet to get me yet. But I must admit, I did not know that Australia had emus. I definitely didn't know that they were dangerous. And I had never heard about a country going to war with an animal before. That was brand new to me. So if, like me back then, you don't know much about the Emu Wars, we're just going to have a tiny little recap here at the start. So it was just after World War I, and new farmers in Western Australia were losing a lot of their crops to the emus. And to deal with this, the army was brought in, and they brought along their cutting-edge Lewis light machine guns, which my illustrator promises me that's definitely how they looked. So when the army was brought along, they were given the goal, kill all the pesky emus. So, with a bunch of soldiers and a bunch of machine guns, Australia went to war with the emu. Now, are there any history experts in here who know who won this war between Australia and the emu? Exactly, yeah, the emus won. So why did they win? Well, there were just too many of them. They were too fast. They were too agile. Apologies, I really should fix that slide. I mean, they were truly agile, as in they could run and jump and hide and be quite nimble. So for those reasons, Australia had to make do with being the runners-up in this war. But to be fair, the Australians, you didn't just lose because of the strengths of the emu. Physical constraints played an important role in all of this. So simply, there were just not enough soldiers and, well, not enough machine guns. Now, in software, we don't typically suffer from these kind of physical constraints. Our weapon of choice is code, and we can always write more code. Now, as we saw just a moment ago, you know, with things like AI and Copilot, we've got so little constraint that it's not a great exaggeration to say that we have near infinite code at our fingertips. And no other industry has this quality. This is kind of our superpower. So, what if we could go back in time and bestow this lack of constraints on those Western Australians? So now they have near infinite soldiers and they have near infinite machine guns. Who's going to win this time? Well, obviously the humans win. You know, with those constraints gone, it simply does not matter how fast or how agile the emus were. I'm afraid they're going to lose out. The good news is, in this scenario, the farmers get to keep their crops. And even better, the bin chicken will finally get to take its rightful place on the Australian coat of arms, which I definitely feel is how it should have been from the very start. So, by translating over this superpower of coding, we've completely rewritten history. But let's play with this a little bit more, and instead of giving those Western Australians of yesteryear our superpower, let's give us, the coders of today, their problem. So, you come into work tomorrow, and the boss says, our biggest client has a problem with too many emus. And we now get presented with this goal of kill all the pesky emus. And you say, that sounds pretty weird, boss, but yeah, sure, no problem, I'll get coding. So I'm guessing most people here are more OO orientated themselves, so let's say that our classes are equivalent to soldiers, and maybe public methods on those classes are equivalent to machine guns. So you come along and you write a class, you add a method, and you manually test it. So we'll have a whole bunch of emus going in, and we've only picked off 2. But to be fair, we've only just started coding. We weren't expecting it to work straight away, were we? And you know, we've got that superpower. There's always more code. Maybe even AI can write some for us. So yeah, we'll add a few more classes that original class probably delegates to, each with their own couple of public methods. And once we've written that up, we'll probably manually test it again. Whole bunch of emus in, and it's better. We've got maybe 5 now, but you've got to remember this is a big problem. This is a complex problem. Although, is there anyone right now thinking that there's like 4 lines of code they could write to make this very trivial? Any ideas?
While loop.
A while loop, beautiful. Just stick all the emus in a loop and be done with it. That is actually the closest thing to real code you will see in this talk, so do enjoy that whilst that lasts. Now, that is a fabulous, fabulous idea, but unfortunately, we're only like 7 minutes in, and it would completely ruin my silly hypothetical here. So what we're going to do is we're going to say that this group of emus is not equivalent to an array of emus, but instead that each emu represents a sort of new and unique problem that we've got to overcome. So, one might be hiding behind a rock. This guy's really far away, and somehow that guy's got his hands on the sword of a medieval knight. I don't know how that happens. It doesn't particularly matter. The point is, this is a truly complex problem now, and that wonderful loop just isn't going to save us. But hey, that doesn't matter. We can write more code, so we're back here, adding a few more classes, and we'll chuck in a whole bunch of emus whilst manually testing. And, see, it's better now. That's a little over halfway. But yes, the boss is probably looking at their calendar, seeing the days and sprints go by, so they're not that happy with us. But in our defense, that's kind of their fault for not knowing how developer estimates really work, isn't it? So we can't worry about their timelines. There's code to be written. Sure, you can see where this is going. We add a few more classes, a bit more code. We manually test in, a whole bunch of emus going in, and that's worse. So some of the emus we thought we'd picked off appeared to be back, and some have got upgraded to T-Rexes. Not entirely sure how that sort of bug can occur, but it's all right. We've just got to look in the code, find out where those bugs are. And yes, the boss is really staring daggers at us now, and we're feeling more than a little uncomfortable. But we'll pull through. Maybe we'll do a late shift. Maybe we'll do a bit of work on the weekend, and eventually we'll fix that up with obviously more code, and we'll manually test it with a whole bunch of emus going in, and hooray! We've cracked it. It finally works. So now, obviously, neither the boss nor the client, they don't really see all that code we've written. To them, it's just a black box, isn't it? So they don't know where all our blood, sweat, and tears went. They don't know where all that effort went. So we don't feel completely 100% appreciated, but who cares? It finally works. Except we just need to get it through code review. Fair enough. Get it through code review. Now our pseudo class diagram, probably the most pseudo class diagram you've ever seen here, has just been giving a very zoomed out view of this code base now. But you've got to remember that more than a couple of sprints have passed, so this PR is now pretty big. You know, this is 2,000 lines or so. Now, I did wonder when I was picking that number how many people would consider that big. I hope you think 2,000 lines is big for a PR. If you don't, you do have my condolences. But that's the number we're going with. So we've got to throw this nice big PR at some unlucky reviewer. And when they come to take a look, you know, it's 2,000 lines of solid blocks of code. And, you know, maybe at best they're going to find us a few typos. You know, maybe they'll find us a couple of emos. If we're lucky, perhaps they'll find us an Elmo that we missed. But really, it's all very complex and very boring. They probably have their own code that they'd much rather be writing. I'm sure we can all relate to that one. So obviously they're just about to give up, and by give up I mean they're about to say, looks good to me, when they realise that we don't have any tests. Right, that's not so good. We are well-meaning professional engineers. Obviously we can't have that, can't have no tests. So begrudgingly we'll start adding them. You know, probably we'll add a test for each class where every other class is mocked out, and every assertion just asserts that the methods output whatever they currently output, because that's a good test, hopefully. But who cares? We've done it. You know, unlike in the real world, with our superpower of near infinite code, we've won our digital Emu War. The thing is, though, you could ask, at what cost have we won it? Now, if you remember, our goal was to kill all the pesky emus, which we'd kind of need to test at this outermost scope, really, to prove that we've done that satisfactorily. So, really, we're just testing at these lower scopes, which mock out everything else. So, are we proving that we can kill all the pesky emus? Well, I mean, sort of. But in fairness and in honesty, not really. Plus, this code base is now pretty complicated. And, you know, our reviewer even gave up trying to understand it. And you could say, sure, you know, that's okay, but at least we understand that. But hey, you know, give that a few months. Obviously been a very rough few months for us. Also, the boss and the client will think that we took far too long on this project. We're dreading the day that they find even more bugs for us. Or even worse, what happens if the problem space develops? You know, what if a couple of the emus learn to ride a skateboard, or one of them invents the flamethrower? Refactoring this horrible code base to deal with those new problems is not going to be fun, not going to be easy, not something we're going to look forward to. So effectively, we've crushed the problem under an avalanche of code. But what does it cost us? Well, it's cost us maintainability and extensibility. Now, I think it would be fair if you're all sat there going, wasn't this meant to be a domain-driven design talk? Because all we've ascertained so far is that Emu Wars are, in the real world, unwinnable, and in code they're winnable but unmaintainable and extendable, which would be a very fair criticism. So, at this point, we're going to move a little bit closer to the real world and add a more realistic domain in here. And not just any domain, we're going to add the ubiquitous, pun intended, DDD presentation domain of e-commerce. So, let's say it's an already established e-commerce store, and there are various APIs for the shoppers, you know, to view products, to see their basket, to pay and to check out. And there are APIs for store managers where they can view customers, see incoming orders, and set them as dispatched. And, you know, this all works fine. Every day, money goes from here to here, and goods go from there to there. And everyone's happy. And sort of just to round this off, let's imagine we've got a whole bunch of microservices working for us in the background, you know, shipping, customers, orders, another for payments, and a last one for products. Because, you know, microservices are still cool, aren't they? Well, I mean, hopefully. I guess we'll find out tomorrow. Anyway, with all this, you come back into work tomorrow, and the boss says, well, the store manager needs to update orders. Okay, well, that's a hell of a lot more reasonable than the Emu thing, so again, no problem, boss, I'll get coding. And so again, we'll write a class, add a method, And maybe that method is wired up to our web framework of choice, taking in some sort of update order command, and somewhere in the body of that class we're getting the order, fiddling with it, saving it, putting it back. And again, for the sake of this talk, we'll keep things simple, and we'll take things like authentication, permissions, security, and logging. We'll take all that for granted, not that we'd ever do that in the real world. So we've already basically written up our update order endpoint, and we'll manually test it with original order going in, and modified one coming out. Looks good. It works. Not only that, but we'll add tests. Nice and easy. The PR is fairly small this time round, and it'll be quickly approved. And we'll deploy it, and the boss will be happy with us. Well, look, this is a live system, so it has users, and unfortunately users use the application. So eventually the boss comes back to us unhappy because they found a bug. It's inevitable. There's always at least one bug on production, isn't there? So what's this bug for us? Some shoppers receive too many items. Okay, it's not great. It's all right. We'll go back to our code. But in looking at our code, it's all very simple, and we don't see anything obvious that would do that. So this time we go to the logs. And finally there in the logs we see a pattern. So the bug occurs when the order is updated to have fewer products, but unfortunately that's happening after we've already okayed that order for dispatch. So that means that the customer receives the original amount of goods and not that sort of updated, reduced amount of goods that they should have got. Well, it's not great. I guess it's an edge case we didn't think about. None to worry, back to the code. We'll add a few more classes to handle this little issue. Maybe this class over here is reaching out to the shipping service to find out if the order was already marked as ready for dispatch. And maybe over here, we're encapsulating a little 400 you can't remove items after we've marked it as ready for shipping error. And I know that probably sounds a bit much for their own classes, but all I'm illustrating here is there is more responsibility now, so that's got to go and live somewhere in our code. Our code base is growing. So, again, wire that up. We do some manual testing, which looks good. We'll add a few new unit tests to our new classes, and we'll get, again, a fairly quick code review. And we'll tell the boss it's fixed, we'll deploy it, and they'll be happy. Well, again, only for a little while because, unfortunately they found another bug for us, haven't they? Okay, well, what's this one? Some shoppers are being undercharged. Now, unsurprisingly, the store manager is particularly unhappy with this one, and we've just had another bug, so obviously we're going to jump on this one pretty quick because not feeling too comfortable anymore. But luckily, we still remember the last bug, and we know it's going to be one of those pesky race conditions, isn't it? It's always a race condition. Let's go to the logs. And again, looking at the logs confirms it for us. So there are updates which add new products that occur after payment was already captured, meaning the shopper gets charged the original lesser price and not that increased price that would have taken into account the newly added items. Right, that's not great, but you remember our superpower as coders. We can always write more code, chuck some more code at the problem. So here we go. We'll add a few more classes, and again, maybe over here we might be reaching out to the payment service and we're checking if payment was already captured. And again, if it was, we'll use some sort of 400 you can't add items after we've already taken payment error to our update order endpoint. Over to the side here are our friends that were helping us out with the other edge case. And I guess because we've got a few scenarios to work out, we've probably got some code above that working out in what scenario the user's finding themselves. And again, we'll do some more manual testing, which takes a bit longer now because we've got all those mounting scenarios to look after. And we'll add the unit tests, which again take a little bit longer, and those ones in the middle are getting a touch abstract, so it's kind of hard to work out how I want to test them, but that's okay. Oh, the code review also takes a bit longer because, again, all that complexity is mounting even for our reviewer. But eventually, even that gets approved, and we tell the boss it's fixed. We deploy it, and they're happy. And I'm sure you know these things come in threes. There was bound to be a third bug, wasn't there? Okay, third bug. What's this one? Some shoppers receive empty boxes. Some shoppers receive empty boxes. Now, that one That one is special. We go to look at the logs, and this time round, we don't actually see anything obvious there. Why are these shoppers receiving empty boxes? And so we look at the code, and again, it's a bit of a mystery there. Our beautifully handcrafted code doesn't seem like it would do that. And it isn't till we overhear the boss saying that this only seems to happen with cancelled orders that a sort of a little light bulb goes off for us. Because if you remember back to the APIs I was discussing earlier, there is no cancel order endpoint. We haven't given the store manager that. It turns out the store manager has been using our nice new update order endpoint to gradually remove every item off certain orders. But unfortunately, the order technically still exists. It's just got no products in it anymore. And our heavily automated warehouse honours that order and ships the empty box on regardless. Now, again, I would forgive you if you're sat there thinking that's a fairly silly, contrived example. But I can tell you that many, many years ago, for a company back in the UK that I may not have worked for, this sort of thing could definitely, definitely happen. So, anyhow, it's just another edge case, isn't it? We know what to do with edge cases. Chuck a bit more code at it. So that's what we'll do, We'll add a bit more code, and maybe what we'll do is we'll sort of remove or invalidate the delivery information once we find the last item in an order has been removed. And yeah, that will now cause empty, broken label boxes to be piling up in the warehouse, but at least the label's invalid enough that they can't get shipped out the door anymore. And maybe in doing all this, we've noticed that our code base is getting really quite complex. So we've reached for the old design patterns book just to see if there's any we haven't ticked off yet, any that we're looking forward to using. And hopefully we're going to look at this mess and use those new patterns to do some really clever refactoring that makes all this complexity much, much better, hopefully. And anyway, we'll do that. We'll do some manual testing. We'll add our unit tests. We'll go through the code reviews again, which is now all taking what feels like forever because of all those mounting scenarios and all of that extra complexity. But eventually we tell the boss it's fixed. Eventually we deploy it, and eventually the boss is happy. Time passes, and it's all right. I'm not putting you through that again. Don't worry. We're actually good this time. I mean, yes, there is still the occasional race condition. Maybe an update happens at almost the exact same time that we're sort of capturing payment. And yeah, the warehouse staff aren't happy with us wasting all of their boxes with that silly little fix we made for the empty boxes. But, these are all rare enough that everyone is still mostly happy. Now, going through this, you've probably noticed that our pseudo class diagram here looks pretty familiar. Now, I promise you, this was not just lazy illustration. I mean, that was part of it, but it wasn't just lazy illustration. This was a heavy-handed attempt at clever foreshadowing. I'll take that silence to mean it worked perfectly. Right, because just like our code-based Emu War from the start, we've solved our update order problem with effectively another avalanche of code. And again, if we asked ourselves, at what cost have we solved this problem, we're going to have a very similar answer. So our problem was the store manager needs to update orders, wasn't it? And again, we need to test at the outermost scope of all this code, really, to prove that update order is working successfully. And that would be even trickier in this case because we've got all that I/O of databases and all those in-process calls to other microservices that possibly we should not be doing. So maybe we've just got a few happy path end-to-end tests, but mostly we're reliant on all of these tests at these lower scopes that are mocking out everything else again. So are we proving that update order works? Well, again, kind of, but, well, not really, no. I don't know about you, but I would have trouble using that bathroom. Again, yeah, tests aren't really proving we're living up to our expectations, so that's not great. And again, the code base is extremely complicated. Although you might say, well, this time we did get it through code review. We split it up into 4 and they managed. But unfortunately, what about a new starter to the team? Unfortunately, they're not going to get that nice incremental view. They're going to have to take in all of this complex nonsense all in one go. And again, how about ourselves in the future? How about ourselves in a year's time if we're paged at 3 a.m.? How's our confidence in thinking that we'll be able to navigate all of this? And again, to the boss and the client, it will be remembered as a slow project. To them, it was driven not by features that make them money, but bugs that cost them reputation and customers. That is not going to be their favourite project to look back on. It's also a code base that none of our fellow developers are looking forward to extending. So just like before, we've crushed the problem with an avalanche of code. And effectively, it's cost us maintainability and it's cost us extensibility. So, often in these moments, us wise engineers, we say things to ourselves like, complex problems require complex solutions. Anyone use that one? How about, you can't remove complexity, you can only move it around. Now, we say these things as a way of sort of absolving ourselves, for the fact that we put some sort of Frankenstein's monster up into production. We're like, well, it has to be that complex. We reassure ourselves. And for the vast majority of my career, I have both been thinking and saying and trying to write off my guilt with these statements. But this is finally where domain-driven design comes into this talk and helps us sort of question a couple of those assumptions. And in doing so, should help us make quite a few benefits to our code base. And where else to start but with a little bit of event storming. So, what we're going to do here is we're going to put up our classic e-commerce events that describe our system, but prior to that update order requirement coming in. So this was before we started doing all that extra work. So, products will be listed, viewed, added to the cart, delivery address will be added, payment details get added, payment will be authorized, order will be submitted, we'll reserve stock, capture payment, confirm the order, send the customer I've confirmed your order email, and at some point later we will pick the stock and finally ship that order. So this is not to say that our system is necessarily event-driven in a technical sense, but these events nonetheless happen in our system. They just might be really implicit in the code. So now let's replay that problem statement that was brought to us. The store manager needs to update orders, which if we just slap the past tense on that, we get order updated, an order updated event. And that sounds perfectly reasonable, doesn't it? So where's it going to go on our timeline? Well, obviously it can't go before the order was submitted because, that's when it first comes into existence. It must have to be after that. So maybe it comes just after the order was submitted or, actually after we've reserved stock. No, it could even happen after we've taken payment or there. It could even happen, in fact, multiple times all across our timeline. Look at them go. And this kind of points out that this order updated event can happen at the exact same time as a lot of other extremely critical events in our system. And if we think back to those bugs we were facing earlier, for example, when the shopper received too many items, the fact that the order could be updated at any time was really the underlying cause of it all. So clearly there is a bit of a modelling smell here. And if you haven't seen one before, that's what a modelling smell looks like. So I'd say that smell intensifies when we look at the language we're using. So in domain-driven design, we often put a large emphasis on ubiquitous language because we want the code and people outside the code to be speaking the same words when they're referring to things. So if we plot these out, what we've been working with, on a scale of domain-specific to hopelessly generic, we might have a few things like, picked, added to cart. They sound very e-commerce-y, very rooted in our domain. Reserved, listed. Well, there's a few that they could pop up in, but, it's still somewhat centered in e-commerce. Then we've got added, viewed. Yes, these are getting quite generic now. But over here in the danger zone is updated. Very much my least favourite of all the words here, order updated. So why is updated such a terrible, terrible event? Well, that is because it is hard to think of a digital representation of anything that could not, in theory, be updated. Phones get updated, games get updated. Even relationship statuses, well, unfortunately now and then they also get updated, don't they? So, when you think about that event, it doesn't really signify much in the way of intent. Well, if any at all. But hey, that was our brief, wasn't it? That's what the boss came to us and they said. They said, the store manager needs to update orders. Okay, well, this is where I must admit I left a few details back out at the start of this talk when we were talking about the Emu Wars. Because there I presented the problem statement as kill all the pesky emus. And that's sort of kind of true, but it's not the whole story. So I'm sure you've all heard of the 5 whys technique before, yeah? It's a wonderfully powerful technique that I must admit we mostly overlook for how simple it sounds. But it's so powerful, it's going to help us with this kill all the pesky emus problem, and we'll still have a couple of whys to spare at the end. So, if you remember that goal, kill all the pesky emus, that existed because the emus kept eating all of the new farmers' crops. Okay, but why? Why were they eating all the new farmers' crops? Well, this was because these brand new farms were set up along long-standing emu migration routes. That sounds like a clever idea, doesn't it? Where should we put the farm? I don't know, maybe where emus have been walking for thousands of years. What could go wrong? Okay, well, why that? Why the need for these new farms, and why in these less than ideal spots? Well, that was because Australia had a bunch of returning soldiers who needed employment. These soldiers were being given these plots of land so they could make their living as farmers. So in reality, the goal was never kill all the pesky emus. That was simply an implementation detail of a possible solution to the real problem of how to find the returning soldiers employment. Now, I must also admit to you that I am not an expert in the early 1900s Australian job market. Unfortunately, they didn't teach that back at school. But I think it's fair to say that there probably were other possible solutions to that problem. And again, I'm sure that no of the alternative initiatives would have been like perfect, but I'm also very confident that none of them would have needed to start an unwinnable war against an army of 6-foot-tall birds, which is a bit of a bonus. Now, with all of that in mind, I'd argue that we were doing the same thing with our update order scenario. That all of that code complexity, which was mirrored in the event storming, its poor testability, and all the bugs that resulted, plus our ever-loosening languages were, again, heuristics or modelling smells, that were trying to tell us that here, again, update orders was another implementation detail masquerading as a problem statement, telling us that we've been focusing on the wrong problem this whole time and effectively fighting our own futile little Emu War. So, if we think back to our bugs, obviously the store manager never wanted like an arbitrary or a random update to an order. When the store manager was removing products, it was to ensure that shoppers could only receive and pay for the items they really wanted. And when they were adding items during an order update, they were allowing shoppers to easily receive extra items that they had forgotten. And lastly, when the store manager was removing all of the products from an order, that was a way of giving the shopper an easy way to back out of an order entirely. So, what you'll notice here is in all of these nice new updated problem statements, none of them are using that horrible word update. So a key takeaway here for you is do not put implementation details in your problem statements. It's very easy to do, but at worst they become self-fulfilling prophecies, as we saw here, and at best they just massively restrict your creativity when coming up with solutions. So let's get rid of that horrible update order API and start afresh. Now again, taking each of those problem statements in isolation, maybe we'll start with allow shoppers to easily receive extra items that they forgot. Now, without update order in our definition, there's probably a ton of ways that we could solve this. The shopper would probably be completely happy with the store manager magically turning up at their front door with the forgotten items in one hand and a card reader in another. I know that would definitely suit me as a shopper, But unfortunately, the store manager would probably prefer we solve this one with code. So how could we do that? Well, a fairly simple solution could be that we imagine a new place supplementary order endpoint. And I know that is horrendously uncatchy, but I'm sure you can all already imagine its signature, can't you? You know, it's going to take in a reference to the original order, a list of the items and quantities that were forgotten, and it's going to output a brand new order that is awaiting payment. And maybe either customer details are cloned or referenced from the original order. Relatively straightforward. And even before we start writing any code, the nice thing we can do is go back to our events and we can sort of do a little bit of sense checking with this. So we've now got supplementary order placed. And the nice thing here is regardless of where we put it on our timeline, it merely spawns a new swim lane of events, which carry on in isolation just like they were any other order, because in many ways it is just any other order. And what we've avoided here are events that come along and contradict or undermine other events that had come before it, which we can already tell will mean fewer calls out to those other microservices, far fewer branches in the code, as it can be more ignorant and decoupled from the wider system, which will also make it a hell of a lot easier to review and to test. And that is just one potential solution to that problem. There may well be better ones out there. But how about these two? Ensure shoppers only receive and pay for items they really want, and give shoppers an easy way to back out of an order. So surely there is no way of solving them without ending up with those fighting events and those rewrites of history again. Well, has anyone noticed this before on Uber Eats? So I've placed my order for some delicious sushi, and it's going to auto-confirm in about 10 seconds. But if I'm quick enough, I can back out of this order if I want to. Or how about this one? You're writing an email, you press send, and you can undo sending that email. How do you undo sending an email? Is it going and deleting it from everyone's inbox? Well, obviously not, no. What is happening in each of these cases is that the system is telling me that these events have happened. But it's only after a certain amount of time has passed that it is letting other services, other systems, the rest of the world, only letting them know after that nice little time window. So maybe we can use that same technique here. So, luckily for us, buyer's remorse kicks in really quickly in e-commerce. Often it is the instant after we click checkout that we realise that we didn't need two of the same t-shirt. Or maybe you didn't have your glasses on when you were ordering your new jar of Vegemite, and then you found them in time for the order confirmation page. Now that horror will kick in pretty fast. Well, at least if you're actually Australian. Now, whatever the cause, we should be able to take advantage of the speed of buyer's remorse here. And we can, think back to our bugs again, that things kind of went wrong when we took payment or shipped orders based on effectively out-of-date information. And if we trace back each of the events and processes that led to that, we'll eventually come back to order submitted. So it looks like that is the guy that would make sense to keep quiet for a little while. And we can imagine doing that in the same way that Uber Eats and that email client did if we make room for a new order received event and back out period expired event in here. So the nice thing here is a typical order will progress along all of these as normal. But should a shopper want to back out of an order or maybe turn it back into a basket that they can then modify, we now have this safe little time window in which they can do so. So, comparing that back to the horrible update order, when order updated came along, it had a large blast radius that could contradict and undermine a lot of the other events in our system, which led to a lot of complexity and bugs for us. But now, with this new solution, when somebody cancels an order, it has a way smaller blast radius that doesn't seem to undermine anything. The events that would have followed it in our system simply now never happen. Now again, this might not be a perfect solution. There could be better ones out there. This is just us developers, speculating. Really, we'd want to get the domain experts together and hash out all the possibilities and possible solutions to make sure they're the right fit for the business. But for argument's sake, and as I haven't provided any of the slides, we're going to run with these guys. So, if we take a look, we've now removed our complex and buggy update order endpoint in Codebase. And we've replaced it with a very simple place supplementary order endpoint. And that one alone allowed us to meet this more specific business goal of allowing shoppers to easily receive the extra items that they forgot. Then we also had a change to the submit order logic, adding a sort of order received, order submitted split, along with a new tiny cancel order endpoint, plus that sort of back out period expired cron job. And those three come together to satisfy those two other far more specific goals. Give shoppers an easy way to back out of an order because they can cancel and leave it there, or ensure shoppers only receive and pay for the items they really want because they could cancel, turn that back into a basket and modify it, adding and removing items to their heart's content. Now, even without diving into the code, it's fair to say that each of these is far more single purpose and less complex than what we had before. And if we revisit those old truisms like complex problems require complex solutions, we can see that we're now benefiting from the other side of that same coin. Simple problems only need simple solutions. And we were able to reach that simple solution because domain-driven design and those other techniques helped us to get around this guy. You can't remove complexity, you can only move it around. Because with our DDD hats on, we can see that this is kind of true, but it needs a few amendments and a pretty big asterisk on it. Because you cannot remove necessary complexity from your current level of abstraction, but go up a level of abstraction because maybe you can remove that complexity from there. Now again, this version is horrifically uncatchy, but it does provide a decent summary of what we achieved in our e-commerce example. But hey, maybe a visualization would be better. So we've got levels of abstraction up and down and timer across the bottom for you. So where we started off, with our mental model prior to update order come along, let's call that V1. Then the problem statement came along, didn't it? That the store manager needs to update orders. And that sort of instantly spawned a V2 mental model of our solution. It was both a problem statement and an implementation, really. And because of that, when we jumped straight back to code and started to implement it, we ended up with that very complex update order endpoint that we didn't particularly like. But with a bit of thought and event storming and following a few of those domain-driven design practices, we came up with a new mental model that was based on that, splitting that very vague update order problem statement into those three far more business-specific goals. And now with those three more specific goals, when we came back to code level, we were able to solve for them with far less complexity than what we started with. So you can actually remove complexity. And this has got to be one of the favorite things that domain-driven design has sort of opened up to me. So often when our solution space is more closely aligned to the true problem space, our business, a whole bunch of complexity actually evaporates. It doesn't need coding for, it just isn't there in the first place. Now I'm sure many of you pragmatic and battle-hardened engineers out there are going, well, that's all wonderful in theory, Lee, but back in the real world, what I've proposed here for our e-commerce system is effectively a breaking change. Yes, well, I must admit that is true. If we've already got our store manager coupled to that update order endpoint, well, we've got to very nicely ask them to stop using that, please. We've also got to get everyone to start using our new endpoints, that cancel order and place supplementary order endpoints instead. And breaking changes and subsequent migrations are painful. And they're also pretty scary, aren't they? And faced with that, many engineers will have a very real temptation not to do them. That instead, we could just stick with what we already had, that update order endpoint. Because yes, it's very hard to test, very hard to extend. New starters take months to get up to scratch with it, but it sort of works, doesn't it? We went through those pains, we've added the edge cases, it sort of works now. But the thing we need to remember when we're considering that is that clients do not care about our implementation details. That inspiration comes to them for a new problem. When it comes to them and they have a new wish that we could solve for them, these are not going to come through the lens of the solution space. They're not going to be shaped by our current implementation or current APIs. Instead, they're going to come through the lens of the problem space. So what behaviors they wish were different, or what new ones they wish they could have. So if our current solution is poorly aligned to the business now, it's only going to get worse as we add new features in the future. And we'll start to stretch a vague, poorly aligned endpoint to take on more and more responsibilities. And I'm not saying that this is necessarily bad code. This might well be the best code ever written, but unfortunately, it is having to deal with a hell of a lot of accidental complexity. So it is obviously quite complex itself. And unfortunately, no amount of wonderful code can make up for crappy API design. That is always a losing battle. So yes, breaking changes are not fun, but it is much better to treat the cause of a problem than to endlessly treat its symptoms. Right, now how do I wrap all of this up for us? Well, unless your domain is either e-commerce or the early 1900s Australian job market. Anyone in that one? No, I'm guessing not. Well, even if they were your domains, the technical and modeling solutions might not be of any direct value from this talk. However, what I do hope you might take away from this talk is a way to prevent your superpower from becoming something of a curse. And the next time that you find either yourself or a colleague 6, 7 classes deep in a problem, which is full of complexity and maybe a few bugs, rather than crushing that problem under yet another avalanche of code, instead you might remember this rather silly talk. Maybe look into domain-driven design if you haven't come across it before. Do a bit of event storming. Maybe check your ubiquitous language, and maybe ask the business why a few times to make sure you're not solving the wrong problem in the first place. And definitely make sure that you're not accidentally fighting your own unwinnable, unmaintainable, inextensible Emu War. Thank you very much. That is all I've got for you.